Welcome to White Paper and Chill with Supra. Today, we're digging into something pretty important in Web3, oracles.
Yeah, a really evolving space.
Definitely. And most people hear oracle and think price feeds, right? Which are vital, sure.
Absolutely essential for DeFi, for instance.
But the way we currently get data onto blockchains, it's starting to hit some walls.
Big time. Especially when you think about scale and the sheer variety of information out there.
Exactly. We're not just talking numbers anymore. We need ways to handle complex real-world stuff and get that info when it's needed, not just constantly flooding the network.
It gets complex fast.
It does. So our goal today is really to cut through that complexity and give you a clear look at what might be next. Think of it as a shortcut to understanding this next wave.
And that next wave, based on this super research paper from May 2025, seems to be pointing towards something called threshold AI oracles.
Right. Threshold AI oracle.
It's not just about moving data anymore. It's about enabling decentralized apps to actually, well, interpret and react to the real world in a smarter way.
Okay, so the need is clear. More capable, more dynamic oracles. And this threshold AI oracle idea, the core, seems to be shifting from, like, always-on data streams
Which can be really inefficient.
to a model that fetches data just in time using AI. Is that about right?
That's the fundamental shift, yes. It leverages AI to be more intelligent about when and what data is needed.
Okay, so let's start with the basics. Why do we even need oracles? What's this oracle problem we always hear about? And why is AI suddenly part of the conversation?
Right, the classic Oracle problem. Blockchains are, by design, sort of isolated systems. They can't just reach out to the internet or any off-chain source and grab data. They need a bridge.
That's the oracle.
A bridge.
Exactly. But traditional oracles were built mainly for data, like price of ETH, simple. But market sentiment during a political crisis? Much, much harder.
They struggle with that kind of nuance, that complexity.
Totally. They often rely on a few whitelisted sources, do some basic averaging maybe. It's not really built for interpreting, say, a sudden geopolitical shift. So it's like trying to understand a novel by only reading the chapter summaries.
Huh, that's a good analogy.
Yeah.
Yeah. And that's where AI comes in. You look at things like GPT-4, AutoGPT. These models are incredible at processing unstructured info.
They can read news, social media, APIs.
All sorts of stuff. And they can even coordinate tasks. So naturally you think, hey, let's plug these into oracles.
But there's a catch, right? AI isn't exactly known for being deterministic or easily verifiable.
That's the tension, precisely. These powerful AIs often run centrally. Their reasoning can be a bit of a black box, and sometimes they just get things wrong. Not ideal for Web3's focus on trustlessness and verifiability.
You can't just have a smart contract blindly trust an AI's output if you can't verify how it got there.
Exactly. And that is the gap threshold AI oracles are trying to fill. How do you harness AI's interpretive power but make it fit within the verifiable, trust-minimized world of Web3?
Okay, that sets the stage perfectly. So let's break down these threshold AI oracles. The white paper mentions several key concepts. First up, just-in-time oracles. How does that differ from the norm?
Well, think of the traditional model, whether it's push or pull, as constantly having data ready, almost like a 24/7 news channel running in the background.
Even if nobody's watching right now.
Right. It generates load, costs gas, can cause congestion. And it might not even have the specific nuanced data you need at the exact moment something critical happens.
Okay, so just-in-time is the opposite.
Pretty much. The Oracle system only springs into action, processes data, and publishes it when a specific request is made or when some predefined condition is met.
Ah, like a trigger.
Exactly. The example given is DeFi volatility. Maybe you only need a deep dive into market sentiment if volatility spikes past a certain point due to some, I don't know, major world event.
So you're not constantly processing sentiment, only when it's actually relevant based on a trigger.
Precisely. The benefits are pretty clear. Less data cluttering the chain, lower costs, potentially better privacy since you're not broadcasting everything all the time.
And it shifts the oracle from just a data pipe to something more like an event interpreter.
That's a key part of it. It becomes more intelligent.
Okay, next concept. Multi-agent committees. Sounds like teamwork for AIs.
It is. Instead of one single AI making a judgment call, which could be biased or manipulated, you use a committee of diverse AI agents.
Diverse how? Different models? Different jobs?
Both. You might have validator agents checking facts, others looking for inconsistencies, maybe a contextual analyst looking at the bigger picture, a summarizer, all potentially using different AI architectures.
Like assembling an expert panel.
Exactly. They access different data sources too. This makes the whole process much more resilient, harder to game. They deliberate, often using natural language, kind of like arguing a case.
So they talk to each other.
In a structured way, yes. The paper mentions an example of interpreting a corporate news release. Different agents might weigh different parts, debate the implications.
And arrive at a more nuanced consensus than one AI could alone.
Right. It builds interpretive resilience and reduces manipulation risk.
Makes sense. But deliberation takes time. The report mentions parallelized reasoning to keep things fast. How does that work?
Yeah, speed is crucial in Web3, right? Especially DeFi. Parallelized reasoning borrows ideas from computing, like symmetric multiprocessing or STM. It lets different committees work on different parts of a query simultaneously.
So multiple AI think tanks tackling the problem at once.
That's a good way to put it. It dramatically cuts down the time from request to response.
How is that managed? Who decides which committee does what?
It starts with Sentry nodes. They get the query, check it's valid, check payment, cryptographically sign it. Then they can break it down and farm out subtasks to the right specialized committees.
So the Sentry node is like a gatekeeper and dispatcher.
Exactly. It prevents wasted effort on invalid requests and orchestrates the parallel processing. And importantly, the system is designed to be fail-soft. Meaning, even if some agents or maybe even a whole subcommittee fails or gives faulty responses, the system can still reach a valid consensus if enough other parts reach their required thresholds. It adds robustness.
Okay, deliberation, parallel work. How does it all come together into something a blockchain can actually use? That brings us to threshold cryptographic signing.
This is the critical link. Once enough agents within a committee, or enough committees globally, agree on an output, they reach a quorum, their agreement is sealed with a threshold signature.
Like BLS signatures, the paper mentions.
BLS is a prime example, yes. It allows you to combine many individual signatures into one single compact signature.
So instead of checking dozens of signatures on chain,
You check just one. It's super fast milliseconds and small, so low gas costs. Plus, you can set the threshold how many agents need to agree depending on the importance of the query.
it's the final stamp of approval, bridging the AI reasoning with deterministic blockchain execution.
Precisely. It ensures only outputs that have passed this rigorous, multi-agent, cryptographically secured consensus process actually make it on-chain.
This whole architecture feels very layered, very deliberate. The report then talks about the overall protocol design and this phased implementation. It seems smart not to try and boil the ocean immediately.
Absolutely. It's a complex system. The protocol itself is a framework using AI, consensus, crypto economics, all aiming for that trust-minimized integration of real-world data. Rolling it out in phases makes perfect sense.
So let's trace the journey of a request. What's a request lifecycle look like?
Okay, so you, or your smart contract, pose a query. Maybe, what's the probability the Fed raises rates next month? Or what's the current sentiment towards Project X?
Okay.
That query goes in, gets validated by a Sentry node, and then triggers the specialized committees to evaluate it in parallel. Fact checkers, context analyzers, inconsistency detectors, they all get to work.
Deliberating within their groups.
Right. Exchanging arguments, maybe in natural language. If a committee hits its internal threshold, it signs its output. These outputs might depend on each other. Sentiment might depend on a factual event confirmation.
There's coordination needed.
Yes, the system manages those dependencies. Eventually, a meta-aggregator component gathers the signed outputs from the necessary committees.
Yeah.
If a global quorum is reached,
Across multiple committees.
yes, then a final global threshold signature is generated. That signed output goes on-chain.
And triggers the action, resolve the prediction market, adjust the DeFi parameter, whatever the goal was.
Exactly, that's the flow.
We touched on the agent roles, but the detail on agent roles and specialization is interesting. Validator, adversarial simulator, contextual analyst, summarizer, judder. It's quite the team.
It really is. And the key is diversity. Different AI architectures, LLMs, symbolic reasoners, rule-based systems accessing different verified data sources. This specialization makes the system robust.
And they mentioned reputation systems.
Yeah, agents could build reputation based on accuracy, consistency, reliability. That could influence role assignment or rewards, encouraging good behavior.
How does that committee deliberation process actually work? How do they argue and agree?
It's structured, inspired by human governance a bit. Agents might contribute arguments round-robin style or all at once. A summarizer agent then tries to synthesize these into a conclusion.
Yeah, and the others vote.
Yeah, they vote accept, reject, maybe contest. If it hits the predefined threshold, great. If not, maybe another round, maybe another summarizer.
What if they get stuck?
There are fallbacks escalation to an oversight committee, potentially even human review for really tricky cases, plus safeguards against bad actors, diversity, staking, randomization.
And coordinating between these committees, the intercommittee orchestration, is key for speed.
Definitely. You want them working in parallel as much as possible, avoiding unnecessary waiting. But if Committee B needs output from Committee A, the system manages that dependency. Each committee's threshold-signed output has metadata, a unique ID. It's a verifiable piece of information that other committees can trust and use as input. Again, diversity in committee makeup and data sources helps prevent manipulation across committees.
Okay, so all this complex off-chain reasoning needs to become useful on-chain. The on-chain integration and that phase output generation seem crucial here. How do you make AI output usable by a smart contract?
That's the challenge, balancing the richness of AI interpretation with the need for deterministic, verifiable inputs for smart contracts. The phased approach tackles this gradually.
Right, phase one, numerical outputs. What's that look like?
This is the simplest form. The oracle returns a number from a predefined set. Think prediction market outcome. 1 for yes, 2 for no, 3 for ambiguous. Or a sentiment score, maybe 1 to 10.
Easy for a smart contract to understand. How is consensus reached here?
Often statistical, like taking the median response from, say, 2 F+1 agents. This provides Byzantine fault tolerance. It can handle up to F bad actors giving wrong answers. Simple, robust, verifiable.
Okay, phase two steps it up. Structured commands. JSON outputs.
Exactly. More expressive. The output could be a JSON object like command, adjust rate, parameters, 5.5 reasoning, increase market volatility detected.
So it tells the contract what to do and why.
Right, using predefined commands. Here, consensus is trickier because it's text. They use embedding models to group semantically similar responses and run natural language inference, NLI tests, to check coherence.
So multiple agents need to agree not just on the command, but on the meaning.
Essentially, yes, you need at least F+1 agents to provide semantically coherent proposals for it to be summarized deterministically. It's more powerful, but securing that semantic space is a challenge.
And phase three, the most ambitious, sophisticated logic generation. AI writing smart contract code.
That's the endgame vision. The AI system interprets a complex request, reasons about it, designs an algorithm, maybe even generates snippets of executable smart contract logic.
Like automatically create code to adjust DeFi parameters based on complex evolving conditions.
Potentially, yes. It's highly complex. It would involve interpreting the request, summarizing reasoning, designing logic, agreeing on parameters.
And verification must be intense.
Extremely. You'd need strong consensus, maybe F+1 agents agreeing on valid logic, plus things like formal verification or simulation before anything gets signed and deployed. Highest computational and security bar by far.
So this phased implementation approach is really about building blocks. Start simple, get it right, then add complexity.
Exactly. Start with numbers, move to structured commands, aim for logic generation eventually. Each phase builds on the core ideas of deliberation and threshold signing.
And that summarization process is key throughout. How does it adapt?
It's tailored to the output type. Phase 1 numerical, median of 2F+1 responses for BFT. Phase 2 textual, convert to embeddings, cluster, run NLI tests on F+1, coherent responses to form structured commands.
Which is vulnerable to tricky attacks, you mentioned.
Yes, requires mitigation like diverse models, randomization, phase 3 logic generation, needs consolidation of maybe 2 F+1 signed proposals, then formal validation, then maybe F+1 signatures to publish on chain. It's the trust anchor in each phase.
Okay, we have AI reasoning, committees agreeing, output summarized. But how do we prove it on chain? The cryptographic verification models discussion is vital.
Absolutely essential for Web3. You need that crypto proof for security, auditability, and just making the AI output actionable in a trustless way.
And the report clearly favors threshold signatures. Why are they the top pick?
They hit a sweet spot. Computationally efficient for verification, super fast on-chain, cryptographically secure. They fit decentralized systems well. That ability to combine many signatures into one compact proof is huge.
Saves gas, scales better.
Right. And you can tune the quorum threshold. Plus, the multi-agent setup inherently makes collusion very expensive and difficult, especially with staking involved.
What about the alternatives mentioned? Zero knowledge proofs, ZK LLMs, ZKML sounds cutting edge.
It is, and ZK proofs offer amazing privacy and correctness guarantees, proving computation happened without revealing inputs. But,
There's always a but.
yeah, generating ZK proofs for complex AI, especially non-deterministic models, is currently very slow. Minutes, even hours. Not practical for a real-time Oracle needing quick responses, and often needs specialized hardware.
So maybe better for audits later, not live results.
That seems to be the consensus, yes. More for ex post verification or compliance.
And the other one? Trusted execution environments, or TEEs. Hardware security.
TEEs create secure enclaves in hardware. They can be very fast, low latency, which is good, but the big trade-off is trust.
How so?
You have to trust the hardware maker, the proprietary code inside the TEE. It's opaque, hard to audit independently, and history shows they can be vulnerable to sophisticated attacks. It undermines the whole decentralization ethos.
So maybe a niche use case, but not ideal for the core Oracle function.
That seems to be the view in the report. Threshold signatures offer better alignment with Web3 principles.
The summary table comparing them on speed, transparency, auditability really drives that home.
It does, and it circles back to the user need, especially in DeFi. You need speed and verifiable trust. Threshold signatures seem best positioned to deliver both right now.
Okay, let's pivot to the real-world use cases. How does this tech actually change things on the ground?
These examples show the leap from simple price feeds to interpreting complex events and triggering on-chain actions. And, importantly, potentially being more robust than systems relying heavily on slower, sometimes gameable, governance votes for resolution, like UMA has faced challenges with.
So that basic request to response to action pipeline.
It's the foundation. Query goes in a parallel evaluation by committees, deliberation sign output with a unique ID on-chain action, like resolving a prediction market. Audit trail included.
Give me an example of event-driven DeFi automation.
Okay, imagine a lending protocol. It could query the Oracle about market volatility and social media sentiment regarding crypto regulations. Maybe one committee analyzes price charts, another news social media.
Working in parallel.
Right. They use embeddings, NLI tests, reach consensus, generate threshold signatures. Their combined outputs feed into the protocol's smart contract, which maybe automatically adjusts interest rates or liquidation parameters based on predefined logic. Much more dynamic than just using price.
Okay, what about dynamic DAO governance? How could a DAO use this?
Let's say a major regulation impacting DAOs has passed. Instead of waiting weeks for proposals and votes, the DAO could query the Threshold AI Oracle. Committees monitor regulatory feeds, news outlets.
To analyze the impact.
Yes, they could deliberate, summarize findings, maybe even propose structured commands, or in Phase 3, draft the actual code changes needed for the DAO's governance contracts.
The AI suggests the code update.
Potentially. After rigorous consensus, F+1 agents agreeing, verification, simulation, the signed output could trigger an on-chain update, allowing the DAO to adapt way faster.
That's powerful. And AI-resolved prediction markets.
Yeah.
It's like a natural fit.
Totally. Mark it on, say, a trade deal outcome. Signed, delayed, canceled. Committees evaluate news, official statements, expert opinions. Agents propose outcomes. The system calculates the median, using 2s+1 for robustness.
And the result triggers the payout.
Exactly. Signed result goes on-chain, settles the market. Potentially faster, more secure, maybe less biased than relying purely on human arbitration or simple voting.
We also saw sentiment-based DeFi automation and AI-augmented escrow.
Right, similar ideas. Adjusting portfolios based on a numerical sentiment score, Phase 1, or resolving a software development dispute, maybe Phase 2 structured commands, by having AI committees evaluate code, docs, communication logs.
And then issuing a signed command like release funds or refund client.
Exactly. Maybe with an option for human review in complex cases. It shows the breadth finance, governance, dispute resolution.
It sounds incredibly powerful, but let's be realistic. The report is clear about limitations and open challenges. This isn't magic, right?
Definitely not. It's a big step, but there are significant hurdles, technical, conceptual, even social. It's important to understand those.
Like aggregating textual deliberation in Phase 2. Getting different AIs using natural language to agree sounds hard.
It is. How do you reliably determine if two complex sentences mean the same thing? Embeddings and NLI tests help, but defining similarity thresholds, handling different models, preventing subtle manipulation, it's tough.
Active research area, then.
Very much so. Current fixes involve using diverse models, randomization, maybe human checks, but it's an ongoing challenge.
And trust in subjective outcomes. If the question itself is subjective, How does a deterministic smart contract handle that?
That's a core tension, especially later phases. Is Regulation X good for the market? No single right answer. Relying just on token votes for subjective things can be risky, as we saw with polymarkets sometimes.
So what's the plan?
Support for appeals, optional human oversight for certain query types, audit trails, and research into interpretive confidence scores. Maybe the Oracle says 70% confident the answer is X.
Then there's the latency versus rigor trade-off. Faster answers might be less thorough.
Generally, yes. Phase 1 numerical outputs can be quicker. Phase 2 and 3 involve more complex deliberation, NLI tests, maybe logic verification that takes time.
So users might need to choose speed or depth.
The protocol might allow configuring that based on risk. Maybe adaptive quorums, lower threshold for low-risk queries, faster results.
What about the AIs themselves? AI model drift and decay. Models get old, right?
They do. Performance degrades if the real world changes and the model doesn't adapt. Mitigation involves version control, constant monitoring, community oversight for updates, benchmarking.
And maybe continual learning models down the line.
That's the hope. Models that learn and adapt over time and are more robust against adversarial inputs.
Which brings us to adversarial attacks on agents or committees. How can people try to cheat?
Lots of ways. Sybil attacks, one person pretending to be many agents, feeding bad data, poisoning training sets, sophisticated attacks on the language models themselves to subtly steer their output. Random committee assignments, behavior monitoring, reputation, anomaly detection. But attacks on embeddings are a real concern. Needs ongoing research in model resilience and interpretability.
And the human factor again. Human oversight and legal ambiguity.
Yeah, if humans step in for ethical calls, who is accountable? How do you prevent that becoming a central point of failure or control? Clear rules are needed. And legally, who's responsible if an AI-triggered smart contract causes harm? The law hasn't caught up yet.
Finally, cost, access, and fairness. Could this tech just empower the big players?
It's a risk. Running advanced AI isn't cheap. Could smaller protocols be priced out? Could decision-making centralize around those who run the best agents?
Potential solutions.
Tiered pricing, maybe quadratic funding for public good queries, protocol subsidies, decentralized governance of the Oracle itself needs careful design to keep it accessible.
So it's clear this is a fascinating direction, but definitely still under construction with real challenges to solve.
Absolutely. It's the frontier, which is always exciting, but also means lots of work still ahead.
Well, this has been a fantastic deep dive. Threshold AI oracles really do feel like a potential next generation for bringing real-world intelligence on-chain, moving beyond just data to actual interpretation.
Yeah, we've covered that phased approach, the nuts and bolts of multi-agent committees and threshold signing, and looked at some really compelling use cases across DeFi, DAO's prediction markets.
And we haven't shied away from the limitations, the open questions around text aggregation, subjectivity, latency, security, and fairness that the research community is actively working on.
So maybe the final thought for you, the listener, is to really consider the implications here. What does it mean when decentralized systems can not only access, but reliably interpret complex real-world information in a verifiable way?
How could that reshape finance? Sure, but also governance, online communities, maybe even how society coordinates.
It definitely prompts you to think about the future of trust, automation, and intelligence in this increasingly interwoven world of AI and blockchain. What comes next?